Hey, good day, everyone. This is Ehsani and Josh Ahumada. We're back on our podcast. This is the third one in the series. If you recall, these are all held on the first Thursday of every month. So,
Yeah. Yeah, welcome back, and most back from vacation.
yeah, I should tell you that I did this unusual thing last month. I was in Italy bicycling along the Amalfi Coast in the mountains of Italy and the coastal areas. Beautiful thing. I cycled about 160 miles and a couple of miles up and down. Put it on your bucket list, folks. It's a great way to spend a week of, enjoy vacation.
Oh, yeah, that's why you're gone. I just started myself here.
And speaking of cycling, in Tucson, we have this annual Tour de Tucson. This year is on November 17th, I think.
It's always right before Thanksgiving.
Yeah.
I usually participate. So
That thing is, come on, maybe you should come and visit us in Tucson for the tour. Yeah.
so this podcast, we said something about the hoop strength, not having to add it, right? And that's, but it might be a little misleading because it's not that we're not adding the hoop strength, but we're not adding the hoop bars, right? Yeah. So that was something that we wanted to kind of cover because it is a unique thing to our product. It is something that it is a bulk of a lot of our designs utilize this. So, I mean, I kind of wanted to first start off with, why do they put in hoop strength on these designs?
So, really a part of this also came about because just this last few days we had a job. It's an overseas job. And I thought, maybe I can share my screen with you and show you. This is, so this is really what we are talking about. You see, typically on a lot of these designs, they could be using both, to strengthen the pile, you'd be introducing new longitudinal bars, plus the hoops or the ties to hold the rebars together. So, one of the challenges with this system is that you have to assemble this cage of rebar topside and then give it to the divers to take it down. And this becomes, it's not a one-man job.
Yeah, and I mean, why is the engineer actually placing this in there? The strength that they're adding. I mean, it's
So that really is because as our engineer friends, appreciate this. If anytime in a column when you have longitudinal bars, you need to have ties on the outside of those bars for both to provide confinement, shear capacity, and basically prevent the buckling of those longitudinal bars when they get actually loaded. So that's really the concept. But now let me show you this, this one project that we were looking at. This is, and I hate, I don't really mean to bash anyone, but this is very typical of what current people design. So
I have to work on it.
So I've tried to, cover, the nothing revealing the project location or, the firm that designed this. But basically here, what they had is a 17-inch square pre-stressed concrete parts that there's some damage here. As you see on the diagram on the left, they identify some of the small area. So they're trying to fix this, retrofit these 17-inch square pre-stressed part. Some of them are about 40, 50 feet tall. They're really tall parts. So the engineer's design, which is shown on this drawing, is that they would cast that another square of tile of concrete around it.
Yeah.
And that, taking it from a 17-inch square, now their design is going to be as we see here, 900 millimeter, which is basically like 35 and a half inch, so this is like the close-up. They're talking about taking that 17-inch, making it more than double, making it a 35 and a half inch by 35 and a half inch square part, which is a lot of concrete. And then their design also includes these ties. So I have shown here, like you see in the upper right corner here in the yellow, I have highlighted, they're recommending to use, which is typical, using 2 U-shaped ties with a 6-inch overlap along the sides of them. This is their design. And so as well,
one of the things I actually now want to bring up, because I mean, that is a lot of work. Our jacket, right? And that what you created was to get around having to put in these ties, these hoop bars.
Yeah.
And maybe if we could take this off, we can show.
Yeah.
Here, we want to take this off the screen. Let's stop right here.
Yeah, you could stop sharing.
Okay. So yeah, this is kind of our jacket, but we got to tell what do we see here?
So this is really the Medic jacket that we wrap around to create our, like stay in place form, if you will. But this is not just a form work. So on here, well, what we are showing here is a 4-inch or a number 4 tie at a spacing of this jacket. When you wrap it 2 times around the tie, it creates the equivalent of a number 4 tie at every 3.8 inches on center, or sorry, 2.8 inches. So almost even less than 3-inch center to center spacing of a number 4 tie. So this is a tremendous amount of tie or confinement that we are providing with this jacket. And so you don't need to provide.
Again, I mean, is that even needed that many ties on?
No,
you don't even really see that, right?
No, the current, like the design that we were just showing you, they were specifying those number 4 ties at every 8-inch or 200 millimeter longer. This is providing you almost 3 times as much tie as that jacket calls for. But the main thing is that you don't have any diver's time to install.
Yeah, those are difficult. So let's talk about, obviously the way that these jackets are constructed, the strength is going in both directions. But when you use cementitious materials, we can't really help. We can't really do the vertical strength. So
so maybe the jacket
and how do we get around that too?
So the jacket really has the same strength as you see here, like equivalent to number 4 rebars at 2.8 inches. It has the same strength vertically too. We are not showing it here.
Cementitious is being the main item we use, and engineers won't.
Because conservatively, typically when you put this jacket around the part and you fill the annular space with a cementitious grout, then we have conservatively always assumed that the jacket doesn't bond so well to that cementitious grout. So in bending, we ignore the contribution of this jacket to the flexural strength of the part.
We have tested it.
Although
that it had been tested.
Yeah, and although Army Corps of Engineers, they have tested it and they tell us that no, the jacket does contribute even if you have a cementitious material. But there are some jobs that we do where we wrap the jacket tightly around the part and we fill the annular space with an epoxy glove. So then they
can calculate.
Yeah, then
what you're seeing going around there,
exactly. So you have basically like a mesh of rebar going horizontally as well as vertically. And if you're using an epoxy grout in the annular space, we take advantage of both of them.
We have brought up spacers in the past, but maybe now, considering what the jacket's doing with these ties, let's go for the space and what is now if you're going to add this vertical strength, how do we do it? Exactly. And easy now, right? Now we don't have to deal with these hoop bars.
So since we don't want to handle the cage of rebar, which is a 2-man job. So instead of that, we use these spaces, and I have a couple of these. These are actually we have gone through so many generations of these over the last decade and updated these. These are the most recent ones that we have just introduced. So they come in either a 2-inch long. This is a 2-inch from the top to the bottom, 2-inch, or the next to it is a 3-inch long. And each of these are designed, what is unique about them is that they are each designed to either receive a number 4 rebar, goes into it, or a number 6 rebar. So it's either you snap a number 6 rebar in and now it's in place. So with the same exact spacer, either 2-inch or 3-inch, you can use it to install a number 4 rebar or a number 6.
The way we have our design in prior episodes, if you caught it, you have the straps, you can put as many of these spacers around. So if somebody wants when I say
Eight up on 10
level 14, they can put that many vertical bars. The
Exactly.
jacket's already got that glue strength. So someone can really create that design how they, to what they really need it for. I mean,
Exactly. So with the, even when we use a lower cost cementitious grout, by putting a few of these rebars in that annular space, we can provide all of the flexural and axial capacity that we need from the that annular space and the rebar. And then of course the hoop comes not by putting individual hoops, but by putting the jacket. The jacket is your hoop, and then you're all done. So you get a lot of a lot quicker. And one thing that some of our engineering friends, they may have had it in the engineering textbook, but I'm sure they have forgotten by now. But there is a beneficial effect from this having so much rebar in this direction. This provides confinement for the concrete. And so let's say, for example, if you have a 4,000 PSI concrete or grouting here, by having a lot of confinement, like what we show here, you can make that concrete work like 10% or 15% stronger than what we put in there. So a 4,000 PSI concrete can work like 4,300 or 4,500 PSI, depending on how many wraps of this jacket around.
a lot of extra benefits.
For the same footprint, you get a lot more bang for the buck. Column to column becomes stronger. The same.
And I wanted to remind anybody if they had any questions. I don't know. We got a chat up. If anyone had questions, they could definitely chat in a question. But yeah, the other thing too is, when other systems like that photo you showed before, when they put the system back, they usually haven't put a metallic back in.
Yeah.
Where we try to avoid that all class. And it's hard to get a hoop bar in metallic, or in an FRP bar, because the way the manufacturing process is, it makes that a little difficult. So, as far as our system, it's very easy to provide a structural design with no doubt.
I wanted to show this screen again for comparison. So really the benefits of this confinement and making it so much more compact. On this project, for example, making that column from 17 by 17 to 35.5 inch by 35.5, this new additional weight of the concrete is 1,000 pounds per foot of pipe. That is a lot of weight. Not only you're paying for all of that concrete, but that weight takes away from the capacity of your parts, because instead of having cargo on your deck of the pier, now you're carrying the dead weight of 1,000 pounds per foot. And imagine if this is, for example, if this is a 40-foot tall part, now you're talking 40,000 pounds of extra weight of concrete. So in this diagram you see here, if we were going to design it like at the corner here, you see that, I have a couple of like little red corn, dots. Those are like a 1-inch spacer that we could put at the corner. And then we would put a medic jacket, a 26-inch diameter part medic jacket would nicely fit around that square part.
Oh, wow.
And now, I ran the numbers. Now, instead of 1,000 pounds per foot, we are only adding 250 pounds.
That's a significant.
Like 750 pounds per foot in just weight of concrete alone savings. And of course, keep in mind again that what we are providing is stronger than the.
Well, that way too, like you said, adding on to the structure. I've noticed a lot of the designs we've provided, even with their other systems, have been able to have people avoid adding all this extra weight.
Yeah,
and that's a great advantage.
This is all about, you're, usually on these, most of these projects, the client is interested in restoring the original capacity of the pile. So if you're trying to do that by adding this dead weight, this is not a wise design, because you're, kind of taking away from that capacity.
So the other thing I was maybe going to touch on is, how do engineers work with us design? So we can provide designs, or we can work with others, maybe a bid package, or
we do it really. We've done it on in both ways. A lot of times we become a support team to the engineering team that already is working on the project. So we can work with them to, if they need, we can provide the calculations for our part design. Usually a lot of these projects, it might be a part of a larger scope of work, but we provide the design for the part, and they include it in their design package, for the entire overall project that they're doing. And, which, oftentimes, we provide seal engineering calculations, drawings, specs, everything for the pile or seawall repair portion of it, and submit it, and then the engineers submit it, to their client.
Yeah, I kind of get that. I talk to a lot of clients and I get that question a lot because to them it's new, right? I mean, they're used to obviously putting in the typical rebar cage, and that has been something. So one thing to mention, was how to get that going. They can all you can always call us, and we're more than happy to assist. Get in touch with an engineer to help assist with the design of utilizing our jacket as your hoop strength.
And the other thing really that this project reminded me of, the project I was just sharing with you, they are using a cathodic protection system. And folks, I get it. Cathodic protection to prevent corrosion of steel is good. But we are, this is the 21st century. Why do you want to retrofit something with a material that it is going to corrode, and then take all these extra measures to prevent its corrosion, and all of that added cost and expense of, monitoring that cathodic protection? So in the retrofits that we provide, we use no steel at all. The longitudinal bars are made out of FRP. The jacket itself provides the confinement and spacers, everything. So this repair that we provide has an infinite life without any monitoring, without any cathodic protection, and you get a much smaller footprint, a much longer lasting, lower cost, easier to install. So there's really a lot of benefits, for these.
You're putting Alex, you're kind of on the clock a little bit. There's what and I'm going to maybe play a little bit devil's advocate here, and I get the question is, what if somebody hits our product, damages it? Can we repair it?
If these materials, they get damaged, in fact, in many ways, they're really easier to repair than other conventional products.
Rebar starts corroding, it's already embedded.
If the rebar is embedded, then you can reach to it. But in our case, the rebar will never corrode. But if the jacket itself is damaged, like you were saying, if it's a small patch, that patch, first of all, most of these, if it's it might be a small dent that doesn't really matter much. But even if it is a larger area that for whatever reason gets damaged, you can easily wrap another laminate on top of that and restore the full capacity of the part, and be back to where you started.
There's an easy repair method, obviously, for when this happens. And I mean, that is a question that I have been asked, because obviously it's an advantage to our system. And what if it gets damaged? At the same time, I know it takes a while for steel, but I mean, you're under the clock when it does go in. So, I mean, it is kind of, a little trade-off on there, where on the, steel with our system, you might have that comfortability with no corrosion. If it gets damaged, it can be repaired.
Yeah, those are that's true. Those are a couple of other benefits of this.
Yeah. So I'm not sure if anyone really has any questions.
The one thing that we want to really remind everyone again, we are offering these podcasts on the first Thursday of the month. This is the third in the series. I invite you to watch the previous two, but also, if you have suggestions for topics that you would like us to cover, we look forward to receiving some feedback from you. Maybe some of you have dealt with some of your colleagues or other people that, we would love to have guests also on the show to talk about, like last week we had Dan Kennedy from the construction side, and he really has a lot of insight on installation. But if you have some other people that you have on mind or specific topics, send us a note, and we
have a couple other guests planned down the road, but also some of those are going to be more maybe design specific, right? Some of them that we want to introduce down the road is like the design I brought up with using low viscosity resin, which remember at that point I can utilize the vertical strength. So that we're going to have a lot of episodes, maybe some that might gear toward the advantages of our system and the design that go around it. So yeah, definitely any feedback is definitely welcome, but stay tuned. There's some good episodes that will break down our product even further. And hopefully we definitely touched on, I think we touched on a lot of questions that we get, trade shows, phone calls. They want to know our system, what that advantage is, more of a breakdown of it. So hopefully that visual, that people might hear that
this is really the main difference, folks. Remember,
yeah.
all of this confinement and this survives equivalent of so much food with this easily installed laminate. That's really the difference. And the fact that then this makes your concrete so much stronger. That's again, something that,
remind everyone, this is 3 inches. But it's technically, but 3 inches on strip. Anyone listening,
number
3 inches on center.
That's really a lot of books. Yeah.
Okay. Well, thank you guys for tuning in, and definitely feedback or just join on the next episode, or we'll have some more interesting topics to go over.